Do you feel the vibes?
All right, so this problem deals with the width of an animal's pupil, right? So we know that, like, if you're in a dark room, your pupils will like dilate in order to let in more light. And then if you're a very brightly lit room, your pupil will contract because it doesn't want to let in too much light so as not to like burn the like rods in the back of your eye, right? So this is an equation that describes the width in millimeters of an animal's pupil, where X is the illuminance of light shining in the pupils, and they are measured in lux, Lux, right? So this is a real formula, right? And again, moving on to calculus, you will just be, given these random situations, right? Because that's what real life math is for, right? Okay. So in things like this, in problems like this, it's important to identify what you have, right? So d of x is the width, and then x is the illuminance, and the units are Lux. So that is important to highlight. Now, as we're moving more and more towards, like electronic, like digital tests, right? Like standardized tests like AP, SAT, and so on. It's becoming more and more difficult for students to highlight and so on, right? On the question itself. So then what you're going to have to be doing is like you have a piece of paper and you're like write down d of x with x is right. So like write it down so you have like a little legend for yourself. Okay, so now what we want is to write a limit to describe the width of the animal's pupils when the light is at its minimum, then find the limit and interpret your results. So when the light is at its minimum illuminance, this means x is approaching 0 because illuminance was x. So now I need to write a limit as x approaches 0. Okay, that means I'm going to need to write the limit of d of x as x approaches 0. And this right there is very important. That notation is important, right? In that way. So now this is going to be the limit as x approaches 0 of this function over 4x to the negative 0.45 plus 10. Now this is a non-calculator problem, right? Okay, so here we have x to the negative 0.45. If you want to see it better, why don't we just rearrange this a little bit? This is 152 over x to the 0.45 plus 85. 4 over x to the 0.45 plus 85. No, plus 10. Come on. Okay, let's simplify this a little bit more, right? So look at this. We can multiply the top and the bottom by the LCD of all the denominators. In this case, it's x to the power of 0.45. So this will be the limit as x approaches 0. What's this? 152 plus 85 x to the 0.45. And then 4 plus 10 x to the 0.45. Right? And I feel like that will give me like a really good function to work with. Right? So now, what is the limit as x approaches 0? Well, this is going to be 0 because 0 to the power of anything is 0, right? And so you're just going to have 152 over 4, which is 38. So, okay, so now it says, interpret your results. And this right here is so, so, so important, right? And okay, so here we go. We're going to interpret our results. This is what we're going to do now, right? This is the part that's the most important here. So this is saying as the illuminance approaches 0, right? What is this that we found? Is it X or D? It's D of X, right? So when the light is at its minimum, the diameter, or sorry, the width of the pupils approach how much? 38. And what are the units? Millimeters. What have we found? X or D? D. We found D. So D, right, is the width in millimeters of an animal's pupil. Okay? All right. Huh? Well, because it's a limit, because it approaches 38, right? Because is the light ever at 0 luminescence? We don't know, right? It's approaching 0, and this is approaching 38 millimeters, right? Because no matter what, like there's always going to be a little bit of light from somewhere, okay? All right, so now write a limit to describe the width of the animal's pupils when the light is at its maximum. When the light is at its maximum, now X is approaching infinity. To find this limit and interpret your results. So now this is going to be the limit as X approaches infinity of D of X. Now look, I already simplified this function to use. So we're just going to use the simplified version. We're not going to reinvent the wheel here. So this is going to be the limit as X approaches infinity of what? 152 plus X, 85, X to the 0.45. 4 plus 10x to the 0.45. All right. So we're going to take this over this, leading term over leading term. The rest is a constant. All right. So we are going to get what? Yeah, it's the same degree, so it's 8.5. All right. So now, as the light approaches maximum illuminance, right, what's happening to the pupils? Approaching a width of 8.5 millimeters, right? So as the light, yeah, right, because as for infinity, that's what we do. Right? As the light approaches maximum luminance, the pupils approach width of 8.5 millimeters. You gotta have the proper units, right? So yeah, so the 152 is, its degree is 0, right? It's x to the power of 0. But this one is an x, it's much bigger, x to the power of a whopping 0.45, right? So that's the leading term. All right? Awesome. Okay, so here we go. Just make it have the quantities, like answering the question, the words approaching, and then the units. Okay. The root mean squared speed measures the average speed of particles in a gas. You should have done this in chemistry, right? Yeah. Defined by this formula, where R is the gas constant, T is the absolute temperature, and M is the molar mass of the gas particles in kilograms per mole. Right. So now we want to find the limit as M approaches 0 of V. Okay, so this is the limit as M approaches 0 of the square root of 3RT over M. So what happens as that denominator approaches 0? What will happen to the function? It gets bigger, so it'll approach infinity, right? So will it approach positive infinity or negative infinity? Positive, because it's a square root. So it'll be infinity slash dne. Right, so what does this mean in terms of the particle, the problem here? What's happening? Uh-huh. Right. Okay, so as the mass of the particles approach zero, right? The average speed becomes infinitely large. Yeah. All right, and that makes sense, right? As the as the mass gets smaller and smaller, the velocity will be getting bigger and bigger, right? So now let's interpret the limit as m approaches infinity. Limit, right, as m approaches infinity of this 3RT over infinity, right? This is going to be 0, right? And again, same thing, right? As the mass of the particles, approach infinity, the average speed will approach 0. You don't say the speed will equal 0. It will approach 0 because the particles will never get to infinitely large mass. So the velocity will never equal 0 either. All right? Yep. So in chapter 10, we talked about sequences and series. And remember we said the series or the sequences might converge or might diverge? Yes? And remember, when did they converge? When they eventually approached what? A finite number, and then they diverged if it didn't approach a finite number or if it approached infinity. All right. So we were given, like on the tests, on the quizzes, these problems, right? Like A sub n, the explicit formula, and then we were like, okay, pick a couple points and see what the pattern is and see if it's converging, see if it's diverging, and so on. So now let's do that, but with limits, right? Because it's fine, right? We can find, I only asked you to find 4 points, but really we should have looked at like infinite numbers of points to really see what's happening, right? So what we found was the point for n equals 1 and n equals 2 up to, wow, n equals 4. But what is that value when n is like infinity, right? That is what we need to find. What happens as n approaches infinity? All right? So here, this is the A sub n. This is the explicit formula. So I said to write the first 5 terms of the sequence. I know you guys know how to do that. We're not going to do that. Yeah, we're not going to do it again. But now let's find the limit. All right? And when we say find the limit of a sequence, we're not talking about the limit as x approaches 0. We just understood that we're talking about, as n approaches infinity. So the limit of A sub n as n approaches infinity is the limit as n approaches infinity of 4 over n squared plus 1. And what will this be? 0, right? Because it approaches 0, which is a finite number, we say it converges. So what if we had something where like the limit approaches -3? What would we say? Also converges. All right. Now this one, we want to find the limit as n approaches infinity of B sub n. So this is the limit as n approaches infinity. And remember, we're just going to take the leading term over the leading term. So in the numerator, the leading term will be given by 9 times n times n times 2n. Correct? How much is that? 18n cubed. And in the denominator, that will just be 6n cubed. Right? So what would that equal, that limit? 3. So this also converges. Okay?